computer, and then I'm going to share Safari and then get rid of this so I don't see my face. Cool. Yeah, well, let's look at that during the lab. Any other admin questions about, or like how the course runs, assessments, that sort of thing? Because I won't go through it again if you've all watched the first lecture and have a pretty good idea of anything. Cool. And if you have any problems getting on the forum, make sure you're using the right login email. So don't include the ad in your email, just zid@unsw.edu.au. You got problems with GitLab, we can talk about that during the lab time. Okay, so that's admin stuff. For the project, Claire will form the groups next week during the lab time. So just like start to chat to people and have an idea of who you might want to be in a project group with. It'll just be like there's no form or anything. You'll just come up to Claire and say, these are the people that I'm forming a group with. And if there's anyone left over, then she'll sort that out as needed. So let's go to VS Code and start talking about some Java. Okay, and we're recording. My screen sharing is paused. Ooh. Here we go. Put up your hand if you've watched the first lecture. Okay, pretty much all of you. Put up your hand if you watched both lectures. Cool. The second lecture doesn't matter too much, so don't worry about it, at least for now. So we're going to start by writing a program that prints hello world. We're going to say system.out.println hello world. And I'm just going to go through stuff to do with Java syntax and things to look out for and kind of the fundamentals of how the language works. Now, in the Java setup lab, we say, here's how you download Java and then you do a Java compilation on command line. That is the only time in the course you need to use those commands. Everything else is done through the run button in VS Code. The reason for that is part of what we're trying to teach you is how to use an IDE, because that's used really widely in industry. It makes your life a lot easier. And at the moment, we've got one file which you can compile, find on the command line. But very soon, you're going to have 20, 30, 50, 100 files in your project, and it's not going to be feasible to do like a C program anymore. So IDEs do all that for you if you have the right setup. Sometimes it takes a bit of tweaking. We can work on that during the lab, but ideally everyone should leave like campus today with everything that they need set up. So I'm going to hit this run button and it prints out hello world. Sorry, what was your question?
So can we turn the lights off just so you can see the projector?
Yeah, sure. So that's a very basic program. Now, how does Java work? Let's look at this and start to dissect it. Java is what we call an object-oriented programming language. And does anyone want to take a stab at what that means?
Yep, it's like class-based.
Class-based, okay. Do you want to elaborate on that?
It's pretty modulated. It's got like you make classes and there's like subsets of classes, subclasses.
Inheritance. Any other? What else about Java? Yes.
Yeah, so you just basically want to make these structures that are unique and use them to your advantage. So it's kind of more organized.
Organized. Yeah, I like what you're saying. Try and find the right word for it. Actually, let's say the word type. Anything else about Java? What do we have? Yep. Yes, we have objects and we have functions, or there's another name for them. Methods, yeah. And what do the methods work with? Attributes, data, fields. We'll call it fields for now. All right, these are probably the keywords. I'm not going to talk about inheritance because that's next week's topic. But we have all these buzzwords like classes, types, objects. We can also call this instances. And we're going to start to sort of work through what these different terms mean.
We talk about abstraction, like you can make classes public.
Yeah, that's a huge idea. And that probably goes up here actually. Abstraction. So let's start with this idea of a class. In Java, everything is an object. And objects and classes are not the same thing. And what I mean by that is, let's say we try to treat this like Python. I'm going to cut this line and paste it here. I'm just, why do we need a class to do anything? All I want to do is print hello world. And we go to our problems and you can see syntax error, blah, blah, blah. Something's not working. And the reason for that is when we say everything in Java is an object, everything in Java is an object, and that you can't even have code that lives outside of a class. And you're probably used to C where you will have seen this something similar to this main method before, but that doesn't live inside anything. That just can sit out on its own. In Python, you don't even need a main method. So everything has to live inside a class in Java. Also, just some syntactic things, you need a semicolon at the end of every line in Java, and this is how you do print statements. This is just a function. Now, that's okay. Let's start to dive into these terms a bit more when we make another class. So we're going to call this next one sum.java, and we're going to go back to our instructions and have a look. So inside a new file, we're going to write a program that uses a scanner class, which reads a line of numbers separated by spaces and sums them. You're welcome to follow along and code this up if you want as well. So we're going to say public static void main string args. Let's look at this now. So it's a main method, right? You're familiar with that from C, where your main method is the entry point to the program. The thing that's executing your program will look for this main method and it'll call that function. And you've got string args as well. That's the equivalent of your int star arg c, sorry, int arg c char star arg b, which is what's arg c? Number of arguments. And what's arg b? Arguments. And what are they? Array of strings. Yeah, which are pointers to character arrays. What we have here is the same thing, except rather than having to pass in the number, we can actually get the number of arguments. If we just say, int length equals args dot length, and that's a property of an array. This is a bit weird, and I'll talk about sort of types more in a second. But the key idea here is you've got this array, and it's an array of strings. But what you will notice is that in Java, if we right click on this and click go to definition, you see that string isn't just an array, like what we were saying before, where it's your char star RB, where it's just a bunch of characters sitting next to each other in memory. String is this whole type here, and there's all this stuff. You don't have to worry about it, but the point is to illustrate that there's a lot going on. And what do we talk about when we say an object? Okay, well, that's interesting. Let's actually make one in the first line of this program. So we're going to say scanner equals new scanner. And then we're going to pass in system.in. And then what we're going to do with that scanner, we need to import it. In VS Code, I don't know what the shortcut is on Windows, but if you're on Mac, you can go command dot, and it'll say, what do you want to import? You can pick which one. In this case, we want java.util.scanner, and it'll just add the import for us. Very handy, very useful. Sometimes it'll even do it automatically. And now what we're going to say is string line equals scanner.next line. And what that's going to do is it's just like the input function in Python, where it says, please enter a message. I'm not going to actually say that, but you get the idea. And I'm just going to run that and show you for now. Here is my line. Now, what's going on here? We've got the scanner and we've got a string. So what we've just done is we've created an object of type scanner. So scanner, just like sum, just like hello world, just like string, is what we call a class. And this is a class. It's a definition for a type. And you can think of a type as the sort of wiffly woffly semantic idea of something. So it's the idea of a sum, the idea of a student, the idea of a hello world, whatever that means. So this is semantic. And the class is the definition of this type, an abstract type, we'll call it. And then an object is a real thing that you can touch and manipulate, and it lives in memory. So when we make a new object, does anyone know what this new keyword might be similar to in C?
No.
Mallet, yeah. So what actually happens under the hood is, let's say here's our memory, and blah, 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 lots of cells. We're going to make a new scanner, and let's say the scanner takes up 4 bytes. It's obviously going to take up a lot more than that in real life. But here's our scanner. It lives at 0x1, 2, 3, 4, 5, blah, 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 blah. And there's some stuff that lives inside here. We don't know what it is, but we know that it takes up a certain amount of memory. And that's what happens when we make a new scanner. Now we can make a second scanner, which is a different object. And we're going to call this scanner 2. And then what's going to happen on line 10 is, here's our next area of memory. And that's, OX, blah, 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 blah. So these are objects or instances of a class. These are real things you can go, this is scanner 1, scanner 2. This is, one student 1, 2, 3, 4, 5. Whereas the class is the definition of that type. Any questions so far? No. All right. So what do we do in the next line when we say scanner dot next line? Well, you think of like a list in Python, and I have a list which is like 1, 2, 3, right? And here's our list. You want to be able to do some sort of manipulation to that list. So I'll say, list dot append 4. Right? And we're invoking some functionality on that list. We're calling the append method. And that's what a method is. We're doing the exact same thing here, where we've got this scanner and we're calling the next line method, a bit of functionality that is attached to this particular object. Right? And we're going to differentiate between object and class block. So that's cool. Now what we're going to do is say, okay, we've got this line, we'll get rid of scanner 2, and we're going to split it into an array. So we'll say string nums equals line dot split. And again, this split method is functionality that is attached to this string object that we've made here. We're going to split it on a space, and then we're going to say for string num colon nums. This is the equivalent of saying in Python for number in nums. Obviously, because actually I didn't talk about this. So Java is what we say strongly typed. Does anyone know what that means? Yep.
You can't redefine or easily typecast from one thing to another. Like in that is sort of weakly typed because I can assign some to input, even though that's a
Yeah. That's a really good point as well. You can think of, so like if I have a function x and then, print x plus or return x plus 1, right? So sorry, I've completely messed that up. Def function takes in a number, return n plus 1. And if I say, okay, function, I'm going to call that with the string hi, it's going to go cannot concatenate, blah, blah, blah. But you can tell me it only gives me that error at runtime. It only actually tries to get to this point and go, hang on, you can't do this. Whereas in Java, if you define a function that says, I take in an int and you pass in a string, it will go, what are you doing? You've just passed in a string to a function that contains that takes in an int, and that will happen at compile time. So every variable that we declare in Java has to have a type, is the upshot. Unlike Python, where it'll just sort of figure it out, and that sometimes causes problems. You may have even experienced those firsthand in your 1531 project when you pass in. You think you're passing in an int, but you forgot to typecast it to an int. It was actually just like the string 1 or something, and that caused a bug. Anyway, so for num in nums, we're going to have another variable called int total equals 0. Now, what's something interesting you notice about this variable total compared to the other ones we've made? It's an integer. What in particular? Yeah. Do you have something? The I is not capitalized. Okay, that's a good point. What does that sort of give you an indication it might be more like? Yeah. It's a primitive. So when we were saying, okay, this scanner here or this string, it's not 4 bytes sitting next to each other in memory. It's this whole sort of pool of memory. And we said it was 4 bytes here, but it's more like this. And it has functions like we've just seen up there. It has data attached to it. It has all this stuff. Whereas in C, it's like, no, these are literally just 4 bytes. Java is kind of halfway between C and Python in the sense that you like at the bottom here you have executable stuff. Then you have assembler or MIPS. Then you have C. Then Python is sitting up the top. In the you just call print and it magically happens. Everything gets done for you. It just sort of works like magic. Whereas C, it's like you have to write your own max function, right? You have to do everything yourself in C. We're pretty familiar with that from previous courses. And Java kind of sits in the middle where it's more abstract than C, right? You don't have to deal with pointers, with memory management and all that sort of stuff. But it's not quite as high level as Python. And this is one of the examples where we actually have primitive types here. This is 4 bytes sitting next to each other in memory. And you get some other languages like C++ and Go, which kind of are between C and Java, in that you get pointers, you get a bit more control over your memory, except you get enough abstraction so that you don't have to deal with everything yourself like you do with C. So that's our total. We say total plus equals integer dot parse int num. And then at the end, I'm just going to say print total. And 1, 2, 3, 4, 5, 6. Answer is 21. Make that a bit bigger. Does anything look a little bit weird about that code, given everything we just talked about? Up back. Sorry, up the very back. I didn't do it. Yeah, you think that's a bit weird because we talked about this idea of you invoke a method of an object. You say this scanner that I've created, I want to invoke the next line method that lives inside that object. But here we've just said integer.parseInt. We'll look at this more, well, you'll look at this more in later weeks. But this is what we call a static method, where the functionality, rather than being attached to a particular integer or a particular scanner, just is attached to the integer class. So you can think of it just as like a utility function. Now, and we've got this word static here as well, which we still haven't really explained. We can talk about it at the end if we have time. We've got 10 more minutes. Is there any questions on any of that stuff that we talked about just then? Yes. It's just like a typecast. So it takes in this num, which is a string at the moment, because we said it was a string up here. And then it's the equivalent of int 1. Oh, yep. Yep.
Does it store all the different functions in the same memory as well, or each individual instance? Does it store
Sorry, could you say that last bit again? It stores.
Does it store everything together? So say for an object, right? Does it also store all of that and all that together, or does it just store all of its attributes?
That's a really great question. We don't get the chance to talk a whole lot about how classes are implemented in memory management and that sort of thing. And if you're interested, do C++ because they talk about how things like inheritance, which is kind of more complicated and dynamic polymorphism works at a lower level. The short answer is, from my understanding, all of the fields, which we'll look at in a second, are stored like a struct inside the object space. And then I can't remember the details, but there's some stuff to do with function pointers, which also is stored in the object itself. I think it might be, I can't remember where because it'll link to the class definition somewhere, which will link to function point, like there's just function pointers to actual areas that the functions live in memory. But I couldn't tell you the specifics, unfortunately. Any other questions? No, right, let's make another class. We're going to call this one shouter. And this is where we start to think of a class as a type. And you kind of know the drill by now. We're going to say public static void main string args. Now, what do we actually need to do in this exercise? Let's have a quick look. Write a program that stores a message and has methods for getting the message, updating the message, and printing it out in caps, and write a main method for testing this class. So now we get to this idea of, well, you know, like before in the sum class, this doesn't store anything. Like this is just a function that lives inside a class. And if this was Python, you wouldn't need a class. If this was C, you wouldn't need a class. So you would just be a function. You know, if this is Python, you would need each main function. The point being, this isn't giving us any sort of conceptual type or meaning. Whereas here, it's a bit tenuous, I'll say, but we're going to start to model entities. We're going to model ideas and concepts as these classes. And this is sort of the foundation on which OO is structured, where you have this idea of student, you have this idea of satellite or I don't know, or a dungeon or whatever, and that becomes a class, and you group your functionality inside that class and the data. So what we're going to have is we'll say shouter equals new shouter, and we're going to pass in I like Java. Now, at the moment, this complains because it says, what does it say? The constructor shouter string is undefined. Okay. Does anyone know what a constructor is? Yep. Creates an instance of the class. Well, your first answer was technically correct in terms of definitions and that sort of thing. But I've made, let's say we don't pass in a string. So I've made an instance of the shouter class, but I haven't got a constructor. Yep.
So I'm thinking of C++.
Yeah.
Does it create it and then allocate things to attributes?
Yes.
What if you have a character of the inside the brackets? It's like create a class and allocate things from the brackets. What do you find that?
Yeah, you're exactly right. And I should say, we haven't explicitly defined a constructor. There'll be like, and it's the same as C++. There'll be a default constructor which runs. But we're going to explicitly say public shouter string message. And what's your name?
Oh.
Owen?
Oh.
And as Owen's very correctly said, the constructor's job is, when we create a shouter, you say, I want to make a shouter and give it this message. I want to make a student and its name is Nick and Z ID is 1, 2, 3, 4, 5. And here's a bunch of data, which is part of the object's creation. And we need a way to say, okay, I'm going to take that data that you've given me and put it inside the class, because we've allocated all this memory and we need to actually say, okay, well, here's your 1, 2, 3 bits of information about the object. We need to actually put them inside those fields. So we're going to say this dot message equals message. And we need a field to actually put these bits of data in. Because at the moment, it's like, what are you talking about? What's this message thing here? Message cannot be resolved or it's not a field. So what we need to say is private string message. And you can think of this like, we don't have time to do it properly, but if we wrote this in C, you have something like struct shouter, there'd be like a type def, and you'd have a message, char star or whatever it is. And then you'd have like, void or shouter, new shouter, string message. Again, this is all fake code, but what you essentially have is, creates a shouter. And you'd have all these functions, and then you'd have your struct, and the data's in the struct, and the functions are what operate on that data. In Java and OO, we just put the two together, and we call that a class. So you've got your functionality, which we haven't written yet, and we've got the data. So we'll get rid of this crap here. And we're going to write a method that says public string get message. And all this is going to do is return the message that's been stored. And what we'll say is here, print line with shouter.get message. Yep.
What's the difference between using message and this dot message inside of the...
That's a good question. So what do we think when we look at the constructor is a problem? And look at the variables.
If you passing like string and or MSG, right? You're going to use this.
That's correct. Why is that the case?
It's when you say this, it's actually in the class or the actual variable, but then you don't use this. We just look for this.
Yeah. So what we have when we enter this function is what we call a scope. And that is the sort of the life cycle of a variable. And if we delete this here, we say message equals message, it's going to go, this assignment to a variable message has no effect because it thinks that you're talking about this thing here. Because it starts by looking at, okay, I'm going to look at the variables that I've got that are passed into the function, the local variables. And it says, okay, we've got this message thing here. But it doesn't realize that there's also a variable in the class scope called message. So to explicitly say, no, I'm not talking about this thing here that you've given me. I'm talking about the field that lives inside the struct, so to speak, of this class. And this is a pointer to the object. This is talking about OX12345. And it says, okay, this, and then the message field inside of that, take the variable message that you've given me in the constructor and put it inside that field. Does that make sense? Cool. I don't know why there are people just kind of staring at the door. It's very weird. What are we looking for next? We need to actually do some stuff. So we've got a method to get the message. Now we want a method to set the message. So say public void set message, and we've got a string message. And what do you think we'll say here? Yep. So we just overwrite whatever's in that field with the new string. And then lastly, we'll say public string shout. And I'm going to return message dot to uppercase. And then here we'll say shouter dot set message. I really like Java. And then we'll say system dot out dot println shouter dot shout. And we'll run that, and it should give us what we want. Yep. I like Java. I really like Java. And that's our first part. So any questions on anything we've talked about all this stuff?
You know, is a public void set message? Is that like setters and section?
Yeah, so it's kind of, and we'll talk about it later, but it's a bit weird how you kind of have this, you know, we make this thing private, and we'll look at later how you can use access modifiers to make things abstract. And the key idea is that someone who's using your class can, all they use is the external functions. They don't actually know how the data works within. And this is a really important concept. And they use the external functions. They don't understand how the data works within. Sorry, I lost my train of thought. Yeah, no clue. Sorry, what was your question again? It was about, oh, getters and setters, that's right. And so what we do is we have kind of these wrapper functions which allow you to, as a user of the class, manipulate the data inside without explicitly going shouter.message equals, this is my new message. Now, this works. This is valid Java. And I'll leave it to you to figure out why that's the case. Any other final questions? Yep. Yep. Which one, sorry? Yes, the constructor is a method of an object. It gets invoked automatically when you run this new, when you create an object, it runs that constructor.
So what's like the actual like why this you're not really doing
Well, you are, in the sense that you're given some, you know, these pieces of information. You say, okay, I want to make a new student, his name's Nick, and it's Z to ID 1, 2, 3, 4, 5. And you need to take that information and bind it to the object itself. And you can just put whatever code you like in here. You could say, you know, this dot message equals message dot to lower. There's no limits on what you actually do in the constructor. Generally, it's considered bad practice to do a whole lot of extra stuff in the constructor. But, you know, if you, as part of your implementation, store everything in lowercase, then that would be valid.
so anything that lets information.
Really anything in a class that's not a field is a method. You either have methods or fields, and the methods obviously act and
So in this
do stuff on the fields.
example,
Yeah, there'll be more fields that are part of the object class, which this class implicitly inherits. But in terms of the stuff we're looking at here, yeah, that's the only field. Cool. I hope the recording worked. I'd be very sad if that didn't work.